Hey everyone, this is Tyler on the OLM team. It's Thursday, March 10th, and we're going to give a quick demo of the progress we've made on Ruckpack. So without further ado, I'm going to share my desktop, which I have to grant privileges to do. Nice. Give me 1 second to do that. Okay, I'll be right back.
In the meantime, I can show off the Ruckpack repository, sort of at a high level how it looks like. And we have pretty informative README that goes over some of the APIs and concepts, as well as some other interesting components that we can go into hopefully a little bit later. But this is basically the repository as it stands now.
Okay, sorry about that. I am back. There we go. You should be able to see my screen. It's a VS Code instance, right?
Yep.
Okay, great. Yeah, so we're gonna be going through some of the common use cases with the Ruckpack repository and its various APIs. So I currently have a kind cluster running locally. So if I do kind get clusters, I have a kind cluster. I'm going to go ahead and run the installation target locally. So it's going to go ahead and install, build the Docker container and install it onto the cluster. It's going to load that kind image onto there, or that Docker image onto there. This is just a local testing image. We have an official image under that same repository for main, where we'll also be pushing other tags for version releases. Okay, so we are installed. So let's see a couple of instances of the resources you'll be creating. So we have this concept of a bundle. A bundle is just a collection of manifests. And as it exists right now, there's no restrictions on what a bundle can contain as long as it's valid Kubernetes manifests. So right here, we're pointing to an image. This image contains a collection of things like a namespace, a role binding, a deployment for the combo operator, which is another project that we're working on. But yeah, so we have two bundles here. We have the v0.0.1, and then we have another one which we're going to upgrade to during this process to v0.0.2. And these both have separate images. So we're also going to go ahead and take a look at the running provisioner. So we have the provisioner running, and we are going to go ahead and watch the logs on that. Okay, I should do a -f. Very cool. So as we're reconciling resources, you can see the logs over here. They're a little bit hard to read. I increased the size of the screen just so everybody can see it on various screen sizes. Okay, so let's go ahead and create these two bundles onto the cluster. So with that, we're just going to run a apply. So okay, apply. I have this samples directory here for the purposes of demoing. So we're going to apply bundle.yaml, which has two bundles again, these two. So they're going to get compiled and applied to the cluster, and you can see it reconciling over here. If we do k get bundles -n, or just their cluster scope, so we can just go ahead and check for them. I'm going to decrease that size a little bit so we can see it. And we see that both of these are in the phase unpacked. While this was running, they're unpacking the resources into a config map under the hood for storage and later retrieval by a bundle instance, which is a kind of an abstraction of a pod. So right now, if you have like a really large bundle, this will go into the unpacking state. And we didn't get to see it now because it beat us to the punch, but there's an unpacking state and then or phase, and then it goes to unpacked once it's unpacked on the cluster into a config map. on the once we so we're looking at the bundles there. On that topic, we can go ahead and check for some config maps on the system. So since we unpacked 2 bundles, we're going to have a collection of config maps which represent the resources of those bundles. So if we take a look at this config map, in particular, we can see some YAML that it has. And we see that it has this binary data field. Under the hood, this is being stored as it's being compressed by gzip. So if we take this data and we plug it into a gzip decompressor online, we see that this is actually just a YAML manifest for a namespace called combo. So if we go ahead and move forward, that's a config map. And then if we look at the config maps again, we have a collection of them. So each of these are representing a different resource in that bundle. And when we go to create a bundle instance, the bundle instance is going to be reading from these and applying them. So let's go ahead and create a bundle instance. Okay, we're just going to go ahead and create it. Okay. Nice. So we created it. You can see it's reconciling over here via the provisioner. You can have multiple provisioners and define your own custom ones. And you separate them via this field right here, this class name. It's the same thing here as well. So this is all hitting the provisioner v0, or the plain v0 provisioner that we've created, which is just the plain manifests. So now if we get bundle instances like this, we can see that the installation of this succeeded. That's a combo bundle instance, which we defined here. That's the name. The desired bundle, which we pointed to, the installed bundle, and the installation state is succeeded. From there, we can take a look at the actual underlying YAML. So let's go ahead and take a look at that. So under the hood, we are using Helm to generate all of this and all of these resources. And this is the underlying bundle instance. If we take a look at some of the resources that get created, let's go ahead and do that. So remember a second ago, we took a look at a namespace. So from the config map, so it stands to reason that we should also have that namespace be applied now that we create a bundle instance of that, which we do. So we just took a look and we found the namespace of combo is being applied. We can also take a look at another resource that bundle provides, which is the deployment for combo, like so. We can see that it is up to date and ready. So now we're going to move into upgrading this to v0.0.2 because we have the 2 bundles. So get bundles, v0.0.1 and 0.0.2. So we want to upgrade to 0.0.2. One thing to keep in mind with this initial version of combo is we have you have to manually upgrade for now. In the future, automatic updates is on the roadmap, but as it stands right now with this initial release, it is manual. So before we get into that process, I want to set a base case. So if we take a look at the underlying image for that deployment that we just looked at, it is using that v0.0.1 image. What we want this to do after we've upgraded is have this be v0.0.2 and also for everything to be in a successful state for combo. So we're going to go ahead and patch this bundle instance with a simple patch command. So we're patching the bundle instance and we are just updating to the new bundle. So if we go ahead and do that, it's going to do some reconciling. If we do a get bundle instances, you can see that the installation is succeeded and the desired bundle and installed bundle are the same. So the installation is complete. If we take a look at the combo deployment again, you can see that we are in a ready state. And then if we go ahead and look at that same thing from before, where we were looking at the version of the image, it has been updated. So, okay, now we've done the upgrade and we want to go ahead and do some deletion. So we want to get rid of all of these resources. So we have the bundles and we have the bundle instance. The desired path to delete stuff on cluster as it currently stands is to delete the bundle instance, and then after that, delete the bundles. If you delete the bundles before you delete the bundle instance, also I see that we're getting some messages in chat. Forgive me for not responding to those. Anyway, so yeah, deleting the bundle before the bundle instance will result in the bundle instance getting a failed lookup for the bundle failed lookup status. So deleting the bundle instance and then the bundle will make that a simple process. So we're going to go ahead and do that. We're going to delete the current bundle instance. So kget bundle instance, just to see we have this currently running. So we're going to go ahead and delete it. Okay, so let's go ahead and run that again. Yep, so that is deleted. So now we're going to delete those other two bundles, the 0.0.1 and the 0.0.2. So go ahead and do that. And now our cluster state is back to where it was before we started adding bundles and removing bundles and things like that. So if we do that, if we try to do that same command where we got the namespaces for combo, it is no longer going to be there, like so. So it manages the deletion of those resources upon deletion of the bundle instance. And that is the demo. So with that, I think we can open it up to questions, and I'll go ahead and stop sharing. Any questions?
Sure. Yeah, this is Joe Heisinger with IBM. I'm trying to understand. So you say, I mean, this bundle contains like a collection of
Okay.
I don't think it's of like super consequence to like the broader Ruckback in general, at least for plain bundles. It seems like an implementation detail that we did this for now.
Yeah, so it's just a proof of concept, right? Because you're just trying to show a kube apply essentially of a plain bundle. So plain bundles, basically resources that you using the apply logic to be able to, I would say it's almost like an apply policy for that bundle, apply provisioner or whatever you want to call it.
It
happens to be Helm.
It's a little bit smarter than that because it's Helm, and that like if the apply fails, it says like, okay, I'll revert you back to what was there before rather than leaving it in an intermediate state. But again, like that's still very much just like a let's throw that in there because we know that it works fairly well, and it's not something that we've defined as like set in stone for how it'll work in the future. So yeah, I think it's like it's just as reasonable to think of this thing as like we're just going to try to apply what's in the next bundle and delete the stuff that's no longer in that bundle.
So there's no like templating. I mean, what's in that bundle you can't like change, provide a values YAML construct to tweak elements in that bundle.
No, and it's not clear that we'd want to do that from at least the install perspective, because it makes it harder to reason about installing things on the fly in the future if there's n different configurations before install time, but actually what combo is attempting to address the thing that we just sampled to install is on the fly configuration at runtime, because those things are templates that you put on the cluster and then you can fill them out to give you that sort of like configurability.
Another point though is that like the RuckPack APIs don't preclude us from building a new controller that knows how to handle Helm charts, right? So this particular demo is for static manifests. If later in the future it becomes like super valuable to have a Helm chart provisioner, like these APIs would work for that just as well.
Okay, I think I got it. Thank you.
So I missed it. Is the bundle resource namespace scoped?
Yes, both the bundle and the bundle
So-
instance, or no, I'm sorry, they're cluster scoped.
Yeah.
Yeah.
Okay.
Scope.
Yeah, because that's kind of the theme of the whole next gen APIs. I think the only thing at the end of the day that you get left with that is namespace scoped will be the catalog source at this point, right?
Yeah, and we haven't really talked about that a whole lot with the new APIs, and in my mind, like that's also subject to change as well.
Yeah, I'm kind of watching that one too with interest because that gets us in a lot of trouble. So we're trying to figure that out too.
Yeah, I think one of the things that we were thinking about was then one of the next provisioners would be a registry v1 provisioner that knows how to like span that gap, and maybe it's also combined with the dependency resolution that understands like some existing APIs, registry v1, and bundles. But that's, I think, still a little while off. It's like the next step.
So the bundle image itself, is it following the general pattern of the registry v1 bundle, or is it completely different, just a directory of YAML files?
We are still kind of hammering out the exact format for that, but I think it's generally what you just said, which is just the plain one is just a directory of manifest files which get applied.
So another question is, are you guys going to follow the, I don't know what it's called, and maybe you, Joe and Rhonda, you can correct me. There is basically this OCI spec that allows you to do store things other than images in a registry, and they don't have to be scratch images, right? Which is kind of how we do them today with bundles. Are you using the new, I think it's the same thing that, what is the name of that command line tool?
Or as
Yeah, using that kind of thought.
an OCI artifact versus an OCI image or a Docker image, just placing artifacts into a registry like Helm 3 has started to do.
Yeah, that, thank you.
So we haven't thought about that yet. One thing that is on the roadmap, I think maybe even for the next like 0.2 of RuckPack, is to add a concept of different ways to source the bundle content. So the next thing is like, let's source it from a Git repository. So I think the idea would be that if there was like, you know, an ORAS, an OCI artifact type, like we could just add yet another way to source from ORAS or from OCI artifacts or whatever.
All right, cool. I just want to comment, I do like the fact that you're using multiple config maps. Now we don't have that gigabyte limit problem anymore.
Yeah, and
Or
they're
megabyte.
so it's each manifest is in a single config map and it's gzipped. So the chances that somehow gzipping one manifest that should originally be less than a meg is somehow not still less than a meg is hopefully 0. So hopefully that
Yes.
just solves the problem.
Yep, I'm with you, that's good.
And we even had talks over the past like day or so about whether we could even offload that further so that it's a volume persistent volume surfaced in the configuration type for the provisioner that runs. so that like it doesn't like it's up to you. Basically, you choose your persistent volume of where you want to store that thing. But I think for now, this works pretty well.
I guess I might be reaching out there a bit, but you mentioned, implementing the registry V1 kind of thing. Is this the place where we would see, like in the future, where you could like do a dry run of installing an operator bundle essentially and have it generate, the effectively what's like the install plan without actually doing it, kind of a thing? Is that fit in this RUCPAC view of the world?
I think at least with this plain manifest type, like if you create just the bundle and then you can go and inspect all of those config maps effectively. And I think we've talked also about potentially having a kubectl plugin that like knows how to like render a bundle on cluster and maybe like print out all of the manifests for you. But in that case, like that would probably be the most direct answer to your question, is that like the bundle tells you what we're going to apply, at least for the plain manifest type. It gets a little more interesting with other manifest types where, if you're going to do templating, are we going to render a template for you before we apply it? And we don't have that concept, I don't think. But that's certainly an interesting thought.
And Joe, are you kind of thinking more about using the Helm dry run command, since if it's templating Helm chart, you could just use that dry run option that's on your Helm templates, see what Helm says about it?
It'd be conceptually like that. I'm just wondering if it would, how it would interact with OLM to generate a dry run version of an install plan or something. I
think what you're getting at is like resolution off cluster for a set of operators or an upgrade, not necessarily a single operator like you were talking about, Joe, right?
Yeah, I'm thinking of more of a an operator with lots of dependencies and whatnot, where you could dry run that thing to kind of get a view of what dependencies it was going to bring in, and that whole.
So we have the separate DEPI/Dipster thing, but that currently works off of subscriptions and catalog sources and a lot of existing APIs. To pull plain bundles into this, I think, is the next step. Plain bundles, and also trying to get down how we want that resolution API to look on cluster. There's a straw man for it called input. That was in some docs that we shared some months ago. But I think we're finally getting around to the point where we might want to start actively working on like a prototype for the resolution. I don't know what you think about that, Joe.
Yeah, I think we're getting close. The nice thing about this architecture is that now, like, we're decoupling the deployment of individual bundles from the resolution of a catalog. So like if you don't want to use DEPI and you just want to install some stuff and you don't have a catalog, like great, that's what RUCPAC's for. And then the other benefit is now that we have this bundle and bundle instance foundation, like we can start building some really interesting tooling on top. Like, right, you could imagine one kind of tooling that you give it a bundle source that might change over time. And what this tooling would do is just constantly refresh the bundle instance to just keep updating it. You could also have one that looks at a catalog, and the catalog has upgrade paths, and we follow the upgrade paths. And then there's obviously like all the dependency things. So the beauty is that this is very much like the pod corollary. Like bundles and bundle instances are basically pods. And we expect that like all of this other stuff that we're talking about in terms of resolution and inspection and workflows is going to be built on top of that. But yeah, I think we're pretty much ready to say like, okay, we've got some of the bits down for RuckPack that actually we can exercise. So let's go start experimenting with some of the DEPI input layer of things.
You know, the thing that's going to come up quickly that was kind of like dry run before is approval. So like how we have install plan approval today, where that's kind of like the dry run of what's going to be applied from resolution, and you can put a manual approval on that and you can prevent it from going in. I think we haven't panned out what approval should look like if it's like ratcheting up. I know we had some like Android style permissions kind of ideas for how we wanted to go with this in like the DEPI RuckPack world. I'm trying to turn this into actionable items, like next steps for us to go to, so that everybody here can join in on the like development of it.
Yeah, the other option, yeah, so the approval stuff is really interesting to me because that's kind of like an imperative step that you take, right? And I've been thinking about this too and trying to figure out like, is there a way to kind of turn it on its side and make it more of a declarative, like, okay, now apply this rather than, or like either create it or don't create it kind of thing. And I don't have a strong answer for that. I think we'll probably start to like have more clarity when we start building the DEPI stuff. But I imagine that like kind of how that works is that what's going to end up happening is we're going to have like another provisioner potentially that the input type is like this whole set of bundles and bundle instances that we want to be applied. And then that provisioner just creates bundles and bundle instances. And now there's another controller for the provisioner for that type that goes and installs those. So it's kind of like building layers of provisioners. And then at some layer is where you basically want to say like, okay, like, yes, create this now. Or maybe it's like a field on the spec that says like dry run. And unless you set that to true, then it's just going to apply the things directly. And it would be like up to you to say like, okay, I don't actually want to apply this, but show me how it'll look. And then there might be another layer on top of that that exercises that spec that, you know, I don't know. So I guess in my mind, like it's unclear to me at what level like is the right to do the inspection and the automation. But another tack we could take immediately is more of like a SimVer based approval flow, which is considering like perhaps like a channel that has multiple minor and major versions of operators on it. Maybe the approval is always approve anything that has just a Z version upgrade, but don't upgrade Y or X versions. So there's lots of different ways that could go, I imagine.
Yeah. It kind of depends on like where the gate is. Like, is it on the bundle? Is it, or sorry, the bundle instance? Is it on the input API? Is it a completely separate API or interaction, or is it a non-resource URL that you hit with a post? You know,
Right.
I think there's some stuff we can take from like the cert approval APIs. But as far as next steps go, is there a prototype we could start working on with a set of acceptance criteria for the input API stuff, like just resolving a set of stuff on cluster and maybe out of DEPI? I'm thinking maybe have DEPI accept, or Depster, whatever the client is, accept things that aren't like subscriptions and catalogs and all that. Have them more be focused on like, give me a set of bundles or packages to resolve and a set of catalogs to resolve over, or some catalog YAML.
Yeah, you're definitely talking about Depster. And I think that we would have to update the resolver to not require some of the underlying OLM resources, which it currently does.
Is that the next step? Is extract resolver on the next step on that dry run road?
Yeah. Next step is extracting the resolver, which Ben Luddy has been doing some work on the side for moving towards. But if we can get that out and be agnostic of OLM resources, and then just have OLM as it currently exists, just call it to some degree, then I think this solves a lot of our problems here, because Depster can do a lot of things, but it requires OLM resources. So once we remove that dependency between those two, it's pretty free in what we can do with it.
Yeah, so can we get a project like board up on that and like some cards with this stuff?
Yeah, I think what I guess the next step would be is to make a resolver repository, and then in that resolver repository, create a project, right?
I think there's another potential approach, which I don't know if there's a good ordering here, which is what kind of Chris was alluding to earlier about catalog sources and whether it makes sense for those to still be namespace scoped, and like, do we still want package server and package manifest? Like, so part of this I think is also what is the mechanism by which we consume the catalog on the cluster with these new APIs? And I think that's probably part of the resolution question, but maybe that's a little bit separate. So we could pursue that path. The other thing that I was thinking, depending on how complex the existing, like rolling the existing resolver in, would be like, what if we said, okay, yeah, like it's really easy to process upgrade edges, but it's really hard to process like the SAT solver and dependency handling and all of that. So like, would it make sense to build something in input, like in Depi land, that just knows how to say like, here's the package and channel I want, produce a thing that tells me my latest bundle instance that I should have installed.
Yeah.
I don't know if that's valuable or not, but like that's just another thought in terms of like a baby step that we could take on the input, not assuming that we have anything existing.
I think it is. I think we should put all these things down in cards written so that we can all read them later.
Yeah, I agree.
I can take that as a story for myself. Try to like open up a Depster/Depi repository so that we can and project, I guess.
Yeah, when you do that, we can pair on that, because that sounds like something I can help out with.
Sweet. Thank you very much.
Yeah.
Are we agreed on that, folks, I guess?
Yeah, that sounded good.
Sounds good.
I'm glad I've coerced everybody here.
I don't know if we explicitly said this, but I think part of maybe Joe's question was, what was it? Can I view, basically like, can I see what the result of a resolution is going to be? And I think whatever we come up with for the Depi API should be able to do that without actually applying anything on the cluster. So
yeah,
like, is there a separate API that thing runs that you can just hit with a curl or something potentially, or maybe it's another API that's an actual resource type that you can persist etcd, but something that's like, just show me what would happen if I said this to you without actually doing anything.
Yeah, it's my thought is that doesn't necessarily need to be an on cluster API, though. Like if we got into the world of API services, we could do something pretty nice with the non-resource URL there. But like generally, if we're extracting the resolver and we give you a way to just call into that externally, as long as you make sure your resolver matches what's running in the cluster, then you should be able to do that all off cluster, right? Like answer that question with the command line tool.
Yes, yeah, I guess it should be both, right? Like you should be able to do it offline, but it seems like it would be super convenient to be able to do it with the version of the resolver that's actually running in the cluster that actually sees what's there as well.
Huh. Well, if I mean, if you have access to the cluster and the controller is the same thing as the tool, then you can just
right. I'm just saying, like, make the controller accessible such that you can make a request to it without it actually applying something.
Yeah,
like, give me the result of the resolution without applying the resolution to the cluster somehow, right? Like, or the dry run or whatever it is.
You know, what's really interesting is this sort of brings up the like the architecture that Docker Moby has, right? So like it's a client server architecture, even with the command line client, and you attach to a running like Docker daemon. And I'm wondering if the resolver can be the same thing. Like you can either be running your resolver engine locally and you attach to that, or you attach to a remote one, which would mean that like you set up some port forward to the OLM API, or even there's a non-resource URL supplied by an API service on cluster that you just hit with whatever this client is, and it uses the resolver running on cluster.
Yeah, maybe that sounds pretty interesting.
Sorry, bike shedding.
So does anyone else have any questions, comments, concerns on the direction of RUCPAC? We're looking to cut a release pretty shortly, so people can start downloading it and sort of playing around with it locally. Doesn't sound like there's any more questions. I don't know if we have anything else on the agenda for today. It looks like it was just the RUCPAC demo. So big thank you to Tyler for showcasing the demo. And I guess we can just let everyone go.
I guess I mean, if we have 1 sec, I guess, I don't know if it's appropriate here, but I'm going to ask. So switching gears really back to like the OPM tooling, like the OPM alpha, the diff command. I'm just trying to get a sense of the direction there. Is that command going to be something? I mean, right now it's alpha, but is it something that we can think that down the road it would be consumable as a way to diff catalogs?
I don't know if anyone else has a perspective. My perspective is that there's still some active work going on, like with the OC mirror stuff that is using some of the diff logic. And I've seen some issues come across the OP, like the operator registry repo, that make me worry that it's getting into the more of the like imperative, apply these specific changes when you do the diff kind of thing to like make it valid and like do merging and stuff like that. And I'm a little bit concerned that that's not the direction that we want file-based catalogs to go in general. So I think that's why it's probably still in alpha, and we haven't really talked about taking it out of alpha.
Okay, but I mean, that's the engine, or somehow in OC mirror, it's leveraging that component, right?
Yeah, so the feedback I gave to some of the OC mirror folks was, if the logic, like if you need logic in OC mirror to do like specific mirroring tasks that are internal to OC mirror, that's fine. Like the external API for that is like a mirroring stuff, but a more general show me the diff between these two catalogs, I think is a little more tenuous as like a general thing that is in the operator registry repo. I don't know if I'm making sense, but I can explain more if you have more questions.
Well, yeah, I guess I'm just trying to get a sense, I think we might be coming up with a use case where we don't actually want to go through and do the whole mirroring thing. We just want to be able to just to generate an FBC, to filter one essentially, right?
Right, and so I'm not sure if diff is the right mechanism for that.
Is there a mechanism for that? I mean, if we have a huge catalog and we wanted to pull bits and pieces out of that, not for mirroring, but just for, subsetting or whatever, is there something?
Our
besides
answer for that is JQ, but like that's like a very coarse-grained hammer that you have to have a lot of knowledge about what you're trying to filter. And I'm guessing what you're getting at is, I want to filter such that I get this package and everything this package depends on, and all of the transitive dependencies. And potentially like only these versions of this stuff, right?
Yeah, I mean, ultimately, that's what we be looking for, right? It's you got this big, huge catalog, and we only want a subset of it because we want to essentially, just offer that subset of things to a developer or whatnot. Not in an air-gapped environment, but
Yeah.
in a pinned, so to speak. You can only deal with these things.
I would imagine that the way to know what you need to filter is going to be something that you have to ask the resolver. And so I would imagine that you would feed the full thing into the resolver on a CLI and say, give me these things with this criteria. And then the resolver can spit you back out a new file-based catalog, or spit you back out something such that you know what to filter. I'm just spitballing though.
Yeah, no, I'm just trying to follow you. So that would be circling back to what we talked about, where the resolver would be externalized and callable to produce that output
yeah.
that you could use. Okay.
Anybody else have any other thoughts there? I'm just kind of going. So if anybody else has any different thoughts or disagrees with me, by all means.
It sounds like we should stay clear of thinking about using that outside of however it fits in with OC Mira is what I'm getting.
That's probably the safest bet. Yeah.
Okay. All right. Thanks, guys. Appreciate it.
All right. Do we have any other conversation pieces? Going once, going twice. All right. Well, let's end the meeting a little bit early today. I'm really happy with how it went. Thank you everyone for attending, and we will definitely have more updates on the state of RUCPAC as we go further and further down the development path. But I think what we demoed today is really, really exciting, and really happy with how it's turning out. With that, I will release it. Thank you.
Thank you. Very good.
Thanks, everyone.